Hello students. So in this lesson we will discuss about the remaining primitive data types, which are real data type, float double, character data type which is char, and one non-numeric data type which is Boolean. Okay, so let's start this one. So at first, as you can see, we will discuss at first floating type or real type. So floating type or real type means these types are used to represent fractional values. So to represent integral values, that means integer values, we use integer data type. Integer data type means byte, short, int and long. As you can see, byte, short, int, long. So these are integer data types. Okay. But here floating data types are of two types. Number one is float. So you need to know the memory size. What is the memory size occupied by a variable of float data type? That is 32 bits, means 4 bytes. Okay. Precision is up to 6 or 7 decimal digits. Precision means the accuracy, the level of accuracy. And the level of accuracy in case of float type is up to 6 or 7 decimal digits. Okay. Default initial value is 0.0f. And what is the range? Range here minus 3.4 e plus 38. E plus 38 means 10 to the power 38, isn't it? This is a scientific notation, and the highest value is, in case of the highest value of range is plus 3.4 e plus 38. That means 3.4 into 10 to the power 38. Okay. And float is used to represent a fractional number with a small range. So if we want to express the fractional number of smaller range, okay, like 2.3, 3.5, then we will use this float data type. That means smaller range, so float data type we will prefer. Okay. Now double data type is here, the memory size is 64 bits. So in case of float it was 32 bits, but in case of double it is 64 bits. That means 8 bytes. Precision is up to 15 or 16 decimal digits. Default initial value is 0.0d, or you can write 0.0. Range is minus 1.7 e plus 308 to plus 1.7 e plus 308. That means minus 1.7 into 10 to the power 308 to plus 1.7 into 10 to the power 308. Okay. Now here you need to know that double is used to represent a fractional number with a wide range of values. So float is used to represent a fractional number with a small range, but double is used to represent a fractional number with a wide range of values. So this is the difference between float and double. And Java treats, as you know, Java treats fractional numbers as of double data type by default. So if you write suppose 2.4 in Java, suppose I'm discussing like this. If you write suppose 2.34 in Java, then Java will consider this value as a double type value. Okay. So 2.34, because double is the default data type in Java to represent fractional numbers. So this 2.34, how will you express? If you want to express this one as a float number, then how will you express this one? We need to add a suffix, capital F or small f. We can write 2.34f, or also we can write 2.34 small f, capital F or small f, both you can use. And if you use only 2.34, then Java will consider this value, this fractional value, as a as of double data type. And 2.34 explicitly you can also write 2.34d or 2.34 small d, capital D or small d, to express uh, as a value of double type. So if you write only 2.34 or 2.34d or 2.34d, capital D or small d, then Java will accept this as a double data type, as a value of double data type. But if you want to express this value as a float, as a float data type, then you need to add this suffix either capital F or small f after the at the end of the fractional number. Okay, so here now we will discuss about character type. Character type, char, is used to declare a variable that can store a character. So you already know what is a character. Character is a literal which is enclosed within single quotes, isn't it? So a character in Java can represent all ASCII as well as Unicode characters. Now you will ask me, what is ASCII characters and what are Unicode characters? Well, there are 256 ASCII characters available in computer. Remember, 256 ASCII characters available in computer. Now what is ASCII value? ASCII value stands for American Standard Code for Information Interchange Value. And each ASCII character is assigned a specific numeric value which ranges from 0 to 255. The least value is 0 and the highest value is 255. Okay, these are called ASCII values. Okay, so each ASCII character is assigned a specific numeric value, ranges from 0 to 255. These are decimal values, are called ASCII value. Okay, now ASCII value for capital A, I am mentioning some characters to represent ASCII values, just like capital A to capital Z. The ASCII value of capital A is 65 and ASCII value of capital Z is 90. ASCII value of B is 66. ASCII value of C is 67. So 1 plus will be added. Plus 1 will be calculated with the previous value of ASCII, and then we will get the next value. Okay, just like the ASCII value, if the ASCII value of A is 65, the ASCII value of A is 65, then the ASCII value of B will be 65 plus 1, that is 66. The ASCII value of C will be 66 plus 1, 67. The ASCII value of D will be 67 plus 1, 68. In this way, the ASCII value of capital Z, you will get 90. So these are the ASCII value of the character, of the letters which are in uppercase. So for lowercase, what will be the ASCII value? For the lowercase, if it is very easy, one formula is there. If the ASCII value of capital A is 65, then the ASCII value of small a, that means lowercase a, is actually 65, then you need to add 32 with that value. So 65 plus 32 is 97. So small b is 66 plus 32, that means 98. Small c is 67 plus 32, that means 99. In this way, the ASCII value of small z, as you can see, the ASCII value of capital Z is 90. So the ASCII value of small z will be 90 plus 32, that is 122. Okay, so these are the ASCII values you must remember regarding these characters. And also I want to tell you that the ASCII value of digit 0 is 48. The ASCII value of digit 1 is 49. The ASCII value of digit 2 is 50. In this way, the ASCII value of digit 9 is 57. Okay, so you need to remember the ASCII value range. As you can see, I have written here capital A to capital Z 65 to 90, small a to small z 97 to 122, digit 0 to digit 9 is 48 to 57. So these are very important. Okay, you must remember. Now these are actually ASCII characters or ASCII value, and I also told about the ASCII value. So ASCII value is actually a numeric value which is assigned to the ASCII characters. Okay, so now what is Unicode? Unicode is actually a more improved coding system. So Unicode is a generalized form of coding scheme of numerous characters of different scripts. That's why Unicode character representation code can represent nearly all languages of the world, such as English, Hindi, German, French, Chinese, etc. So ASCII characters, there was a limitation that 0 to 255 ASCII values, that means total 256 characters are there. ASCII characters, there are 256 ASCII characters, and these are limited. ASCII characters are limited, but here, as you can see, the Unicode characters are actually more than that of ASCII characters, isn't it? Because Unicode character representation code can represent nearly all languages of the world, such as English, Hindi, German, French, Chinese, etc. So the characters which are used in German language, the characters which are used in Hindi language, the characters which are used in English language, etc. Can be represented using this coding scheme, Unicode character representation code. Okay, and since Java supports Unicode, it makes Java a truly universal language. And why not? Java supports all the characters that are used in these languages, nearly all languages of the world. So that's why Java is a truly universal programming language, isn't it? Now Unicode contains hexadecimal numbers ranging from 0x0000 to 0xFFFF. So after 0x here 40, and after 0x here 4f. So this is the least value of Unicode character range, and this is the highest value of Unicode character range. And these values, as 0x is written in front as a prefix, as you can see, so these values indicate that these are the hexadecimal values, you must remember. In case of ASCII values, these were there were 256 characters, and these values 0 to 255, these are actually decimal number system values. Okay, but these values are hexadecimal number system. So if you convert these values into decimal number system, you will get the range 0 to 65535. That means 65,535. That is the highest value, which is equivalent to 0x FFFF in hexadecimal, and 0x0000 is equivalent to 0 in decimal. Is that clear? So there are how many Unicode characters used in Java? 65,536, because it starts from 0. That's why 65,536 Unicode characters are used in Java programming language. Is that clear? Now I want to tell the size of the character data type. So the size, the memory space that is occupied by a variable of char data type is 16 bits. Remember, the data type is char. Okay, so 16 bits, that means 2 bytes. And default initial value is within single quote you need to write backslash, then u, then 1 2 3 4 4 zeros you need to write. So within single quote backslash u 1 2 3 4 zeros. This is known as null character. Is that clear? Now one thing I need to tell you about the size, that 16 bits for 2 bytes. So if you want to express ASCII characters, then it can occupy 8 bit. So ASCII characters need 8 bits in the memory, but Unicode characters, as these are the hexadecimal values, that's why Unicode characters need 16 bits, and that's why overall for char data type 16 bits is reserved in the memory. Okay, now so all numeric data types are discussed. Now we will discuss about the non-numeric type, which is also a primitive type. So that is Boolean type. So it is a primitive data type. Obviously, whatever the data type we are discussing at this moment, All are primitive data types. So now we can tell that it is used to declare a variable that can store a Boolean value, and Boolean value means you already know, true or false. These two values are together called Boolean values. So true or false are actually non-figurative values. I'm underlining this one, non-figurative values. Non-figurative values means actually abstract values. Okay. So true or false are actually non-figurative values or abstract values. These values are used to check whether a logical condition is satisfied or not. If a logical condition is satisfied, then true is stored in a Boolean type variable, and if the logical condition is not satisfied, then false is stored in a Boolean type variable. Is that clear? So Boolean type of values, the Boolean values true or false, are non-figurative values or abstract values. Okay, and these values are used in while checking a logical condition. If the logical condition is satisfied, then true will be stored in variable, and if the logical condition is not satisfied, then false will be stored in the variable. Okay, now the size is 8 bits. That means 1 byte, but it uses only 1 bit. As you know, 0 means true and 1 means false. So 0, 1, 0, these are called bit. So they need actually 1 bit in the memory. If you want to store false, that means you are storing actually 0. Okay, 0 in binary. False means 0 in binary and 1 means true in binary. So if you indicate true, that means you are storing binary 1 in the memory. So these are known as bit, as you know. These are known as bit. Every binary digit is known as bit. So they need only 1 bit of memory, but they actually reserved 8 bits in the memory, but it uses only 1 bit. So you must remember this. And the default initial value of Boolean data type is false. Is that clear? So all primitive data types are discussed now. So that's all for now.